So this is Calculus 1, Lesson 7 on the derivative of a function. That's a really big deal. That's what we're going to spend most of the semester studying, and the tangent line problem. So part of what we want to do is to find a way to understand complicated functions. So you have a function y equal f of x, and the graph might look something like that. This is not very good, but some complicated thing. And it's hard to understand this in some sense. The simplest functions are straight lines. Right? That's about as easy as it gets. And the equation of a straight line, which you learned in high school, is y equals mx plus b. And if you have a curve which is sort of complicated, you would like to find a way somehow, at least at a certain point, to approximate it by a straight line. Okay. And the analogy is with a circle. So we have the picture of the tangent line to a circle. Here's a circle. Here's a point on the circumference. And we'd like to find a line that we call the tangent, which touches the circle at exactly one point. If you take 2 points on a circle, it's easy to find a line through those 2 points. We call such a line a chord. A chord is a line that cuts a circle at 2 different points. And whenever you have 2 points, you just, put a line through them, put a ruler through them, and draw the line. That's a chord. But a tangent touches the circle at just 1 point. And it's not so obvious, I think, to figure out how to draw the tangent line to a circle. So one thing you can do is the following. Here's the circle. Let's say you want the tangent line at this point. You can take another point, and different from this, and draw this chord. And then you could take another point a little bit closer to this point P that you're interested in, and draw the chord through these 2 points. And you can take a point even closer to the point you're interested in, and draw the chord through those 2 points. And what you learn in geometry, at least intuitively, is that as you take a sequence of points getting closer and closer to the point you're interested in, these lines have a kind of limit line, and that limit is the tangent. So these are chords, and as you take the chord through your fixed point and the second point is getting closer and closer to the fixed point P, these chords approach a limit. So the tangent line in the circle is the limit of a sequence of chords. So think about what you're supposed to learn in geometry. These chords approach the tangent line. Now we can carry that over to calculus.
Excuse me, Professor, can you repeat that one more time, please? You said the tangent is what?
So this tangent line is the limit of a sequence of chords.
Thank you.
So I have this point P, and I take another point different, I draw the chord, because through any 2 points, you can always draw a line. And then I take a sequence of points along the circle, getting closer and closer to P, and this produces a sequence of chords. And the limit of that sequence of chords is the tangent line. I mean, to prove that rigorously is complicated, but to understand it intuitively is not complicated. And it's good to develop a kind of geometrical intuition about these things. Now, we carry this over to the problem of find the tangent line to a curve, which is the graph of the function f of x, at a certain point, C. So the picture we have is the following. If you look at the graph of y equal f of x, let's say it looks like that. And here on the x-axis, this is x equals c. So this point on the curve has coordinates c comma f of c. Right? Those are the coordinates of a point on the curve. And what we can do is choose another point different from C. Let's say this point over here. So this point is, let's say it's C plus some quantity delta x. So delta, this is the capital Greek letter delta. And delta x means a small quantity in the x direction, just some small number. Sometimes we use the letter h, but the text is using delta x. So here's the value x equals c plus delta x. And this point on the curve has coordinates c plus delta x, comma f of c plus delta x. Those are the coordinates of that point. And now we have two different points on the curve, and we can draw the chord, the straight line between them. So what is called the secant line is the line, the straight line, through the points CF of C and C plus delta x, comma F of C plus delta x. I have these 2 points, and I draw this straight line between them. What is the slope of the secant line? Well, we basically have a triangle. This is C and this is C plus delta x. And this height is f of C. And this height is f of C plus delta x. So the distance from here to here is delta x. That's what we called the run when we were talking about straight lines. And the distance from here to here is f of C plus delta x minus f of C. That's the rise. Slope is rise over run. It's f of C plus delta x minus f of C divided by delta x. So the slope of the secant line is exactly this. Let me do an example just to try and make this a little bit more concrete. Suppose we take the parabola. Y equals x squared. So my function f of x is x squared. So my parabola looks like that. And this point, if I choose C equal to 1, f of C, which is f of 1 is 1 squared is 1. This point has coordinates 1, 1. Suppose I take delta x equal 2. Sorry, delta x equal 1. So C plus delta x is 1 plus 1 is 2. And f of C plus delta x is f of 2, which is 2 squared, or 4. So that's the 0.24. This is the 0.11. And the secant line, through those 2 points, this is my secant line. And what is the slope? The slope is f of 2 minus f of 1 over my delta x, 2 minus 1, which is 1. F of 2 is 4. F of 1 is 1. 2 minus 1 is 1. This is 3. So this secant line has slope 3. Let's do another calculation. With the same function, suppose let c equal 1 and delta x equal a half. So c plus delta x is 1 plus a half, or 3 halves. And this point on the curve, f of c plus delta x, is f of 3 halves. That's 3 halves squared. Our function is y equal x squared. That's 9/4, 2.25. So I get another secant line. And it's going through the 2 points, 1, 1, and 3 halves, 9/4. What is the slope of this secant line? Well, the rise, the line goes from 1 to 9/4. So it's 9/4 minus 1, and x goes from 1 to 3/2. 3/2 minus 1. So this is 5/4 over 1/2, which, if you know how to do fractions,
Tenfold.
is 2 times 5/4, which is 5/2, or 2.25. Right? Sorry, 2.5. So is there a question?
No, I was giving you the solution.
Right. So this secant line has slope 5/2. When you had delta equal to 1, the slope, well, the secant line was 3. When delta is 3/2, the slope of the secant line is 2.5. And
Quick question.
go ahead.
The first example you gave us, I see at the end you wrote equal to 4 minus 1 over 1 and got you 3.
Correct.
You see that? And then you see the one above that, f2 minus f1 divided by 2 minus 1.
Yes.
How did you work from?
Well, f of 2 is, so the function is y equal x squared. So f of 2 is 2 squared.
Oh,
So f of 2 is equal to 4.
okay.
F of 1 is 1 squared, which is 1. So this is 4 and this is 1.
Okay. Thank you.
Yep. Any other questions? So the general picture, again, is the following. We have a function y equals f of x, and we want to find the tangent line at some point x equals c. So here's the graph of this function. And let's say here is x equals c. And what we do is for some small delta x, positive or negative, we look at the point c plus delta x. We look at the corresponding points on the curve. We draw the secant line. And the slope of the secant, rise over run, is going to be f of c plus delta x minus f of c divided by delta x. And this thing is called a difference quotient. And we define, so this is a definition, the slope of the tangent line at x equals c as follows. We take this slope of the secant line, and then we take a limit as delta x goes to 0. And this number is what we will define to be the slope of the tangent line. So let's look at an example. Suppose we have the function, well, I looked at a moment ago at x squared. Let's say, let me choose the example in the book, f of x equals x squared plus 1. And let's find the slope of the tangent line at x equal 1. So when x is 0, this is 1. When x is 1, it's 2. When x is 2, it's 5. This parabola looks something like that. And here on the graph is the point 1, 2. So how do we find the slope of the tangent line? At c equal 1 or x equal 1. I take f of c plus delta x minus f of c over delta x. What is that? C plus delta x, that's 1 plus delta x, minus f of 1 over delta x, because I'm choosing c equal 1. My function is the argument squared plus 1. So this is 1 plus delta x squared plus 1 minus 1 squared plus 1 divided by whatever delta x is. Okay. So this is the definition of the difference quotient, f of c plus delta x minus f of c over delta x. And I'm choosing c equal to 1. So this is 1 plus delta x squared plus 1 minus 1 squared plus 1. When I square this, I get 1 plus 2 delta x plus delta x squared plus 1. And when I square 1, I get 1 minus 1 plus 1. So the 1 plus 1 and 1 plus 1, they cancel. This is just 2 delta x plus delta x squared over delta x. And I can factor a delta x out of the numerator. I get 2 plus delta x over delta x. And these delta x's cancel. So this is 2 plus delta x. So the slope of the tangent line is the limit as delta x goes to 0 of this difference quotient. That's the limit as delta x goes to 0 of 2 plus delta x. And when delta x goes to 0, 2 plus delta x just goes to 2. So the tangent line has slope 2. And it passes through the point 1, 2. Sorry, passes through, 1, 2, passes through the point 1, 2. Okay, so here is a problem in pre-calculus you have to be able to solve. I have a straight line, the slope is 2, and it passes through the point 1, 2. So what is the equation of the line? Work it out and tell me. We have this parabola. Here's the point 1, 2. We have a line with slope 3. Sorry, with slope 2. find the equation of the line. Can someone tell me what it is? If you have a line with slope m, and it passes through the point AB.
Hello, Professor.
Yeah,
I think y is equal to 2 plus 2x.
y equals 2x. Does that pass through the point 1, 2?
No, I'm saying 2 plus 2x.
2 plus 2x.
Yeah.
So when x is 1, this is 4. But when x is 1, it's supposed to be 2, because this point has to lie on the line. So if you have the line that goes through a point x1 comma y1, and if you take any other point xy on that line, to say that the slope is m means that the rise y1 minus y, or let me do it the other way, y minus y1 over x minus x1, that's the slope. If you're given the slope and a point on the line, any point on the line has to satisfy this equation. This is y minus y1 equals m times x minus x1, or y equals m, x minus x1 plus y1. So this is called the point slope formula. Which you have to know, right? And in our case, the slope m is equal to 2. The point on the curve has x1 equal 1 and y1 equal 2. So y is m, which is 2. X minus x1 is x minus 1 plus 2. This is 2x minus 2 plus 2. The 2's cancel and it's 2x. So the tangent line has slope, the equation of the tangent line is y equals 2x.
Wow.
Okay. So this is important, and here's another example to give you a little bit more chance to practice. Suppose we have the function f of x equals 3x squared minus x minus 2. So this is also a parabola because it's a quadratic. Find the equation of the tangent line to the curve that goes through the point, let's see, when x is minus 1, 3, 4, minus 1 comma 2. Right? So this is a parabola that goes through this point. Find the equation of the tangent line. So the first thing to do is to compute the difference quotient. So c is equal to minus 1, and f of c is equal to 2. The difference quotient is f of c plus delta x minus f of c over delta x. This is f of minus 1 plus delta x minus f of minus 1 over delta x. F of minus 1 plus delta x is 3 times minus 1 plus delta x squared minus minus 1 plus delta x minus 2. Right, that's what this is. Minus f at minus 1. When you plug in minus 1, you get 3 plus 1 is 4 minus 2 minus 2 over delta x. So this is a calculation, right? When you square this, you get 1 minus 2 delta x plus delta x squared. Minus minus 1 plus 1 minus delta x minus 2. Minus 2. When I distribute this across, I get 3 minus 6 delta x plus 3 delta x squared plus 1 minus delta x minus 2 over delta x. Now I notice 3 and 1 is 4 and minus 2 is minus 4. Those cancel. So I'm left with 3 delta x squared minus 6 delta x minus 7 delta x over delta x, which is 3, if I factor out the delta x, 3 delta x minus 7. Right. So you should look at this for a minute, because this is a basic calculation that you're going to have to do 100 times in this course, computing the derivative of a function by computing a difference quotient. So what this tells us is for the difference quotient, f of minus 1 plus delta x minus f of minus 1 over delta x. This difference quotient is just 3 times delta x minus 7. And if I take the limit of this as delta x goes to 0, it's the limit of this as delta x goes to 0. That's minus 7. So the slope of the tangent line is minus 7. The tangent line goes through the point minus 1 f of minus 1, which is minus 1 2. So we have the point minus 1, 2, and a line going through this point with slope minus 7. Find the equation of the tangent line. And you remember the point slope formula. The line through the point x1, y1 with slope m has the equation y equals m, x minus x1 plus y1. So just make the substitutions and tell me the equation of the tangent line.
Is it y equals minus 7x minus 5?
Well, let's see. So y is equal to the slope minus 7, x minus x1, which is minus 1, plus y1, which is 2. So this is minus 7x minus 7 plus 2 is minus 7x minus 5. Right? So the tangent line is that. And one way to understand what is called the derivative of a function is that it is the derivative of a function f of x is the slope of the tangent line to the curve y equal f of x at a given point. And the notation for the derivative, right? So there's several notations. F prime of x, dy dx, y prime, capital D of y, the dx of f of x. These all mean the same thing. They're just different notations for this. But the definition is the derivative, I'll write it as f prime of x. It's the slope of the tangent line at x. So that's the limit as delta x goes to 0. Now I'm using x instead of c. F of x plus delta x minus f of x over delta x. So this is the limit of the difference quotients. So this is the fundamental definition of the derivative. And in the course of this semester, we'll learn various tricks or techniques, if you like, to calculate derivatives. But the first thing you have to know, and this is always a question on the final exam that the department makes, is to use the definition of the derivative to compute a derivative. So let me do an example. Of course, it does involve generally a lot of calculation. So let me recall, first of all, again, the definition. F prime of x, this is the derivative of the function f at x, is the limit.
Professor, excuse me, I cannot see your handwriting.
That's all there is to say. the limit as delta x goes to 0.
Professor, you hear me?
Yes. Can you see this?
Yeah, I can see that. But the first one you said is f of x, or what? It's
F prime
very,
of x.
it's very light. Yeah.
F prime of x.
Or f prime of x.
Yes,
Oh,
the
okay.
derivative.
Yeah, I can see it now.
The derivative is f of x plus delta x minus f of x divided by delta x. That's the definition. So here is a typical problem that f of x be the following function, x cubed plus 2x. Compute the derivative, f prime of x. Okay, well, let's do it in several steps. This is f of x. What is f of x plus delta x? So when we evaluate the function x plus delta x, that's x plus delta x cubed plus 2 times x plus delta x. Right? Let's expand this. How do you expand x plus delta x cubed? Well, we've done that several times for other functions. This is x cubed plus 3x squared delta x plus 3x times delta x squared plus delta x cubed plus this plus 2x plus 2 delta x. That's f of x plus delta x. So what is f of x plus delta x minus f of x? It's all this minus f of x. So that's minus x cubed plus 2x. And we can see there's cancellation. There's x cubed and minus x cubed, and 2x and minus 2x. So these 4 terms are canceled. And what we're left with is this, 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 and this. That's 3x squared delta x. Here I have a 2 delta x, so that's 3x squared plus 2 delta x plus 3x times delta x squared plus delta x cubed. And if I want, I can factor the delta x out of this. I have 3x squared plus 2 plus 3x delta x plus delta x squared. So if I take f of x plus delta x, minus f of x, and I divide by delta x, I just get this. And if I take the limit as delta x goes to 0, that's the limit of this as delta x goes to 0. 3x squared doesn't change. 2 doesn't change. But as delta x goes to 0, this goes to 0. And delta x times delta x goes to 0. I'm just left with this. So I've solved the problem. For this function, the derivative is 3x squared plus 2. Right? So I started with the function f of x is x cubed plus 2x, and I found the derivative.
Excuse me, Professor.
Yeah.
Can I just see the top of that page real quick?
That's just the definition.
Oh, okay. All right.
Professor,
Yeah.
can we do that another way, very short?
What do you mean by very? This is how you compute it using the definition. How would you do it otherwise?
Or like you said f of x equal x to the power 3 plus 2x's, right?
Yeah.
So if we bring the 3 down, we will get 3x to the power 3 minus 1.
Okay.
plus-
So
plus-
you're using something which we haven't proved yet, and we will prove it very shortly. But
okay,
the rule is always answer the question. Okay.
yes,
That's so. If the question is find the derivative of x cubed plus 2x, any way you find it that's correct is a correct answer.
thank you.
All right.
Yes.
But if the question is use the definition of the derivative to compute the derivative, then this is what you have to do.
All right.
Okay.
Professor,
Yes.
how did you get the 3x squared plus 2 at the end by itself?
Okay. So I have this line. Let me write it down on the other side. I have f of x plus delta x minus f of x over delta x. When I do the calculation, what I get is 3x squared plus 2 plus 3 times x times delta x plus delta x squared. Okay? And let's look at this term. X is fixed. If I take the limit as delta x goes to 0 of 3x times delta x, that's going to be 3x times 0, which is 0. Delta x goes to 0, so this all goes to 0. And the limit of delta x squared as delta x goes to 0 is 0 times 0, or 0 squared, which is 0. So when I take the limit, this term goes to 0 and this term goes to 0, and all I'm left with is this. This doesn't involve a delta x. This is like a constant with respect to x.
I see now. Thank you.
All right. I mean, this is complicated when you're learning it for the first time, but that's just the way it is. It's like, you know, it's in the beginning, it's very hard. Now, it does take some algebraic skill to compute these limits. And let me do a couple more. Suppose we have the function f of x equal to the square root of x. And we want to compute using just the definition of the derivative f prime of x, which is the limit always of f of x plus delta x minus f of x divided by delta x as delta x goes to 0. So what is this difference quotient? F of x plus delta x minus f of x over delta x. This is the square root of x plus delta x minus the square root of x over delta x. I'm just substituting in what the function is. And this is kind of hard to figure out. So I tried to, what is often called, rationalize the numerator. I can always multiply by 1. And I'm going to multiply by 1, but 1 in the form square root of x plus delta x plus the square root of x over the square root of x plus delta x plus the square root of x. Right? Because this is just, I have the same thing in the numerator and the denominator. So I'm just multiplying by 1. And I see what I get in the denominator is delta x times square root of x plus delta x plus the square root of x. And the numerator, this is of the form a minus b, a plus b, which is a squared minus b squared. It's this squared minus this squared. When I square the square root, I get x plus delta x. And when I square the square root of x, I get x. And these x's cancel. This is just minus delta x over delta x times the square root of x plus delta x plus the square root of x. And I have a delta x in the numerator and the denominator, so they cancel. So this is minus 1 over the square root of x plus delta x plus the square root of x. That's this difference quotient. And then I take a limit as delta x goes to 0. When delta x goes to 0, this just becomes square root of x plus the square root of x. And 1 plus 1 is 2. So I get minus 1 over 2 times the square root of x. And that is the derivative of the function. So, oops, let's see. I think I made one mistake somewhere. Let me just double check. Square root of x plus delta x minus square root of x. This is delta x. Yeah, I don't know why I put a minus sign there. There's no minus sign. This is x plus delta x minus x is delta x. So this is plus 1 over 2 times the square root of x. That's the correct answer. So, you know, it's always good if you have the book to have the book next to you during class, because you can also follow on the book, which makes things clearer. While you are enjoying this, I will just double check the attendance. I have Amin, Menal, Negron, Leonardo, Atkins, Gordon, Bello, Fletcher, Bertazzulli, Tillett, Lozano, Reyes, Ram Narain, Beltran, Segura, Soto, De La Cruz, Garcia, Vega, Fahim, Alcantara, Ondago, and that seems to be everybody. Okay. Let me do a few more of these because this lesson, which is extremely important, is learning how to use the definition of the derivative, the fundamental thing about the derivative, to calculate the derivative. And again, on the departmental final, I don't make it up, but the department makes it up. But every year, every semester, there's always a problem to use the definition of the derivative directly to compute a derivative. So here's another example. We have and it doesn't matter whether the variable is x or t or y or u. So in this case, we have the function y is a function of t, and it's very simple, perhaps, just 2 divided by t. So let me calculate the difference quotient. The first thing I need is 2f of t plus delta t minus f of t. That's 2 over t plus delta t minus 2 over t. And then you have to know how to subtract fractions. I have t times t plus delta t in the denominator. Here I have 2t minus 2 t plus delta t. So this is t times t plus delta t in the denominator. In the numerator, it's 2t minus 2t minus 2 delta t plus 2t and minus 2t cancel. I get minus 2 delta t over t times t plus delta t. That's the numerator of the difference quotient. And when I take f of t plus delta t minus f of t and divide by delta t, I get minus 2 over t times t plus delta t. And then I want to take the limit as delta t goes to 0. As delta t goes to 0, I have t times t plus delta t. When delta t goes to 0, this just goes to t. So I get minus 2, t times t is t squared. So when you have the function f of t equals t over t, the derivative f prime of t is minus 2 over t squared. Now, we were perhaps lucky because in all the problems I just did, it was possible to calculate the derivative. But the derivative is a limit. And sometimes there are limits that don't exist. So let's look at another example. So here's a nice example. F of x is the absolute value of x minus 2. So you remember the meaning of absolute value. This is x minus 2. If x minus 2 is greater than or equal to 0, and it's minus the quantity x minus 2, if x minus 2 is negative. So this also can be written as x minus 2 if x is greater than 2, and minus x minus 2 is 2 minus x if x is less than 2. So when x is greater than or equal to 2, it's the line with slope 1 going up like that. And when x is less than 2, it's the line 2 minus x. It's the line with slope -1 and y-intercept 2. So this function is a V-shaped curve. Now, let's try to calculate the derivative. So I want to calculate the limit of x plus delta x minus f of x over delta x as delta x goes to 0. So what I want to do is to try to compute the derivative at the point 2. So I'm looking at f of 2 plus delta x minus f of 2 over delta x as delta x goes to 0. Of course, f of 2 is 0. So this is the limit as delta x goes to 0 of just f of 2 plus delta x over delta x. And it makes a difference whether delta x is positive or negative. So let's calculate the one-sided limit from the right, the positive sign. So when x is greater than 2, this function is x minus 2. So this is the limit as delta x goes to 0 through positive numbers. F of 2 plus delta x, that's 2 plus delta x minus 2 over delta x. The 2's cancel, that's the limit as delta x goes to 0 through the positive numbers, delta x over delta x, which is 1. So the limit from the right is equal to 1. Right? This has slope 1. What about the limit of f of 2 plus delta x minus f of 2 over delta x when delta x goes to 0 from the left for negative numbers? Again, f of 2 is 0. We don't need that. And
We can't see where you're writing.
sorry. So it's the same limit as this, except now delta x is approaching 0 from the left. So 2 plus delta x is less than 2. Of because delta x is negative. And so if 2 plus delta x is less than 2, this function is two minus 2 plus delta x. This function f of 2 plus f of whatever this is, f of a, is 2 minus a. Here the a is 2 plus delta x. So it's 2 minus 2 plus delta x. The 2's cancel. This is the limit as delta x goes to 0 through negative numbers of minus delta x over delta x, which is minus 1. So you see, when we take this limit from the right, the limit is, the one-sided limit is 1. When we take this limit from the left, the one-sided limit is minus 1. They're different. So this function has one-sided limits, but they're different, which means the limit doesn't exist. So this function has no derivative at x equal 2. Right? Derivatives don't always exist. The derivative is a limit, and limits don't always exist. So in this function, we have a limit from the right and a limit from the left, but they have different values. So there's no limit, there's no derivative. Okay. Now there's another kind of what you might want to call misbehavior on the part of a function where you also do not have a derivative. And there's a nice example in the text. This is the function f of x equals the cube root of x, or x to the 1/3. And find, if it's possible, the derivative at x equals 0. So if you take f of x plus f of 0 plus delta x minus f of 0 over delta x, f of 0 plus delta x, that's just delta x to the 1/3 minus f of 0, which is the cube root of 0, which is 0, over delta x. Delta x to the 1/3 over delta x is 1 over delta x to the 2/3. And as delta x goes to 0, this goes to plus or minus infinity. Actually, it goes to plus infinity. So an infinite limit means the limit doesn't exist. No limit. So f of x equal x to the 1/3 has no derivative at x equals 0. Now, there are a number of problems, homework problems, that go with this section, and they involve typically using the definition of the derivative to compute a derivative. So let's look at one of them. So this is homework problem number 7. We have the function g of x equals x squared minus 9. So g of 2 is 2 squared minus 9, or 4 minus 9, or minus 5. So find the slope of the tangent line to this curve. at the point 2, -5. And the first thing you say to yourself is, well, the slope of the tangent line to a curve is just another name for the derivative. So we're being asked to compute the derivative of this function, g prime, evaluated at 2 from the definition of the derivative. So you should spend a few minutes now trying to do this, and then I'll do it. But it's really important to try to do these things. Okay. So using the notation g of x, g prime of x is the limit as delta x goes to 0 of g of x plus delta x minus g of x over delta x. And x equal 2, g prime of 2 is the limit as delta x goes to 0 of g of 2 plus delta x minus g of 2 over delta x. G of x is the function x squared minus 9. G of 2, 2 squared minus 9 is minus 5. So this is the limit as delta x goes to 0. You plug 2 plus delta x in for x. 2 plus delta x squared minus 9 minus g of 2, which is minus 5 over delta x. So work that out for a few minutes, and then I'll finish the problem. Let's see. The limit as delta x goes to 0. When I square this, I get 4 plus 4 delta x plus delta x squared minus 9 minus minus 5 is plus 5. And 4 plus 5 minus 9 is 0. So I'm just left with these two terms. I can factor out a delta x. I get 4 plus delta x. These delta x's cancel. So this is the limit of 4 plus delta x as delta x goes to 0. So when the delta x goes to 0, this is 4. So that's the answer. But I mean, this is really the answer. So here it's not getting the numerical answer, which we'll learn how to do very quickly in a week, but understanding how to use the definition of the derivative.
Professor, I have a question.
Yes.
Where did you get the 4? Like,
So I'm not
because
sure which 4 you mean. Here?
when you, oh yes, you see the 2 plus delta x squared.
Right. So in general, a plus b squared is
I
a
see, yes.
squared plus 2ab plus b squared. So here,
Okay,
a is 2 and b is
Yes.
delta x. So
okay.
that's 2 squared plus
Mhm.
2 times delta x
I
plus
see.
delta x squared.
Thank you.
And 2 squared is 4 plus 2 times 2, 4 delta x plus delta x squared. Yeah, that's where it came from. I mean, you have to be very careful that you do the algebra correctly. Okay. All right, well, I don't want to jump ahead and I don't want to do all the homework. So this is lesson 7, and it really is fundamental. And I encourage you to spend as much time as possible reading through the text, checking line by line all the examples that are worked out in the textbook, and doing as many homework problems as you can, because this is really important stuff to learn. Okay. Well, are there any questions? If not, then I guess we are done for the day.